All right, let's look at a key component of research. Suppose we're going to do a research project. What are the steps? What are the components do we need to have in order to have a successful research project? These are the key steps. Number one, a research must have a research issue. All research starts with questions. Psychology asks many questions about human behavior and human functioning. For example, I'm interested in anxiety. I'm particularly interested in anxiety disorders. I can ask a question, why do some people suffer from anxiety disorders? Why do some people worry so much? Why are they so nervous? Why they tend to be stressed out really easy? This is my question. In order to answer this question, I come up with theories. Many theories have been proposed in psychology to explain anxiety, depression, friendliness, conscientiousness. Many theories have been proposed in psychology to explain human differences. For example, I have a theory about anxiety. My theory says anxiety or anxiety disorder is usually created by traumatic experiences. This is my theory. So I'm proposing anxiety disorders can be caused by earlier traumatic experiences. How do I test my theory? Remember, we cannot test whether a theory is true or not. We cannot prove a theory is true once and for all, but we can test a hypothesis derived from a theory. If the hypothesis, which is a specific prediction based on the theory, gets supported, we say the theory receives empirical support. According to my theory, which says anxiety disorders may be caused by earlier traumatic experiences, I can derive hypotheses. I can generate several or rather many specific predictions based on my theory. If my theory is right, what can I predict? What should I observe? One observation or one prediction is, if I study different people with anxiety disorders, I shall be able to find that most of them have earlier traumatic experiences. This is a more concrete prediction than my theory. Well, I should be more specific than this. So my prediction may say, suppose if I do a case study, if I investigate, say, 50 cases of individuals who have been diagnosed with anxiety disorders, who have been diagnosed by qualified doctors as having anxiety disorders, and then if I interview these 50 people, I should be able to uncover that most of them have suffered some kind of a traumatic experience before they developed anxiety disorder. For example, they might have suffered criminal attack, violent attacks by some aggressive people. They might have experienced the bully in school, and they might have experienced some parental abuse, domestic violence, or they might have witnessed some domestic violence when they were small, when they were growing up. This is a specific prediction based on my theory. If my theory is supported, I should be able to find this evidence. This is a hypothesis. I can generate other hypotheses. For example, I can generate another hypothesis which says if we give an animal traumatic experiences, this animal will later develop anxiety disorder. For example, if I get hold of 50 rats and if I give them electric shock, painful electric shock in their home cage every day for 2 weeks on a row, and then by the end of 2 weeks they should become really nervous, really anxious, really fearful. They should develop some symptoms similar to the human anxiety disorders. This would be another specific prediction. This would be another hypothesis derived from the same theory. Once you have figured out a prediction, the specific prediction, a hypothesis, you know how to make observations. Based on your predictions, you will be able to design a research and to test your theory, to test your hypothesis. A research design is simply a way to gather information, to collect data, to make observations, and analyze your data. If your data analysis support your hypothesis, then you can say, my theory receives empirical support. These are the key steps or key components of scientific research. First, you identify a research issue, you ask a question, a specific question, and then you come up with a theory, which is a tentative answer to your question. And then you can figure out the prediction based on your theory, which is a hypothesis. Next, you design a research. You come up with a research design to guide you to gather information, collect data, to test your prediction, which is your hypothesis. And then you analyze the data and draw conclusions. You conclude whether your hypothesis is supported or not. These are the key components of research. Next, let's talk about how we do that. In order to complete these steps, we need to understand a very key concept, a very critical concept. This concept is called variables. When you are composing a research issue, when you are formulating a theory, you use concepts or variables. You use variables. A psychological research issue is a question about the relations between psychological variables. And a psychological theory is a statement or proposition about relations between psychological variables. Now let's look at what variables are. What is a variable? To vary is, can you replace the word vary with another word? To vary is to change. To vary is to differ. To vary is to take on different values. A variable is a characteristic that can take on more than one values. Let's look at a variable in the human body. Can you think of a characteristic, a human characteristic, a physical characteristic that varies from person to person? Different people have different values. Height, body height is a variable. Some people are taller, some people are shorter. Men tend to be taller than women. It is a variable. Body weight is a variable. Some people are overweight, some people are underweight, some people have the appropriate weight. Height, weight are variables. Can you think about a psychological characteristic that is a variable? People vary in introversion, extroversion. Some people are more outgoing. Some people are more introverted, are shyer, are more socially anxious. This is a variable. And aggressiveness is definitely a variable. Intelligence is a variable. Intelligence is a variable that can be measured quite precisely with IQ tests. So a variable is simply a characteristic that can take on different values, more than one value. Are there characteristics that only have one value that is not a variable? Can you think about a characteristic, a human characteristic that is not a variable? What do we call these kind of characteristics? They are called constant. If a characteristic is not a variable, then it is a constant. It has only one value. An example would be the number of a head each person have. The number of eyes, we have only 2 eyes. All people have the same value. All people have 2 eyes. All people have 2 ears, 1 nose, 1 head, 5 fingers on each hand. These are constants, not variables. We are interested in variables. We are interested in how people differ from each other, how people have different values on different variables. Variables are very important in psychological research, in all scientific research. There are 2 broad ways we can measure a variable. One way to measure a variable is called a nominal variable or categorical variables. These variables measure qualitative differences. Gender is a qualitative variable or categorical variable or nominal variable. Gender has 2 values, at least 2 values, male and female. These are qualitative differences. You cannot do math on these values. You cannot add them. You cannot subtract. These are qualitative differences. Ethnicity is a categorical variable. It has different values. Asians, Africans, Europeans, etc. Attitudes can be measured as a qualitative or categorical variable. For example, we can have a positive attitude toward social distancing. We can have a neutral attitude, or we can have a negative attitude towards social distancing, or any object. Another way to measure variables is numerical variables. Numerical means numbers. Well, these are numerical differences. These are quantitative differences. You can talk about more or less in terms of how much on this particular characteristic. For example, generosity, how much money you are going to donate to a charitable fund. This can be measured as a numerical variable. Say you can donate $1, $10, $20. Every time you go to Walmart, you check out, the cashier could ask you, do you want to donate to the children's hospital today? You can come up, you can tell her how much you want to donate. This is a numerical variable. IQ scores, intelligence is a numerical variable. Depression is a numerical variable. You can measure depression on a Likert scale, 0 to 6. Say 0 means you are not depressed at all. 6 means you are extremely depressed. The numbers in the middle, 3 or 4, 2, these are moderate levels of depression. So these are numerical variables. The prevalence of mental disease can also be measured as a numerical variable. For example, we can measure what percentage of people suffer from depression, what percentage of the population suffer from anxiety disorders, say what percentage of people suffer from schizophrenia in a particular country or in a particular community. These are numbers. These are numerical variables. Let's look at details of numerical variables. Numerical variables can be measured at least 2 ways. One way, a more crude or less precise way of measuring numerical variables is rank order variables. And a more precise way of measuring numerical differences or quantitative differences is equal interval variables. Let's look at rank order variables first. Rank order is just a rank order. We can rank order people, say in a race, in a marathon race, you are the champion, and then the second place got the silver medal, and then the third place got the bronze medal, and you have the 4th place, 5th place, 10th place, etc. These are rank orders. You can say the first place gold medal winner is faster than the silver medal winner, and then who is in turn faster than the bronze medal winner, but you cannot say how much precisely, how much is the difference. Say, let's look at some real data, real world data. This is World Health Organization's statistics on the coronavirus cases. Well, it has rank orders. It has provided rank order of the different regions. Which region, which part of the world have the largest number of cases? According to the World Health Organization, as of today, July 22nd, well, the Americas, North America and South America combined, have the largest number of cases and rank number 1. And then the second place is Europe. Europe has less cases than America, but more cases than the other regions. Rank number 3 is Southeast Asia. And then you have Eastern Mediterranean, number 4. Africa is number 5. The region with the least number of cases actually Western Pacific. This would include East Asian countries, China, Japan, Korea, etc. This is a rank order variable. Which region has most cases? Which region have least number of cases? You can rank order them from top to bottom, from the most largest number of cases to the least number of cases. But you can measure the cases most precisely. You can measure exactly how many cases each region has. For example, Americas, South and North Americas combined as of today has, let's say, 8 million, well, more than 8 million cases. You can count exactly how many cases it has. Europe has more than 3 million cases. And Western Pacific, on the other hand, has about 845 cases. The number of cases is equal interval variable because the interval between one case and two cases is equal to the difference between two cases and three cases. And so if one place has two cases and another place has four places, the second place has twice as many cases as the first cases, the interval or the unit of differences is constant in equal interval variables. So with equal interval variables, you not only know which one has more cases, which place has more cases, which place has less cases. You also know how much more. That's equal interval variables. Let's look at another interesting variable. This is the number of cases, daily new cases reported in Germany. You can say, let's see, in March and early April, they have two peaks. On 2 days, on two short periods, they reported many new cases relative to the other days. And then the number of cases started to decrease in early April and keep decreasing, but there are periodical spikes. There are periodical sudden increases in cases over the entire period of time. But the overall trend is that the new cases are decreasing. The number of cases each day is an equal interval variable. Well, let's look at another example of equal interval variables and rank order variables. This graph shows the number of coronavirus deaths per 100,000 inhabitants. So this measures with each 100,000 inhabitants, or with each 100,000 citizens, how many deaths are reported due to coronavirus infection. Let's look at rank order. In terms of rank order, in Europe, Belgium is number one. Belgium has the largest number of deaths per 100,000 people. And UK, the United Kingdom, ranks number 2. Spain ranked number 4. Italy ranked number 5. And then Sweden, France, Ireland, Netherlands. So these are the rank orders of different countries in Europe, from more cases to less cases. But we can have a more precise measurement. We can measure the specific number of cases per 100,000 people. This would be in equal interval variable. Belgium ranks number 1. Well, they have 85.55 cases per 100,000 people. And UK is ranked number 2. Precisely, they have 67.97 cases per 100,000 inhabitants. These are equal interval variables. A case is a case. Two cases will be twice as many as one case. 4 cases will be 4 times as many as one case. You can do math on this equal interval variable.